All right. Hello, hello, hello. This is very exciting. We're going to do intro to WebAssembly today. We have our guest, Dominic Elm, who actually kind of, and this was quite my, so, okay, so here's what happened, right? I've been friends with Dominic since he came to, he came to hang out with us in Texas a couple years ago, and we were organizing a training together, and we became friends, and he's so cool. And then he went to work at StackBlitz. And so now he's become like the StackBlitz superstar, right? Because you know StackBlitz is, I love it. I love StackBlitz and I love Dom, and then they're together doing really cool stuff. So now he's like even cooler than he was when I met him. And so we asked Dom to come on Angular Nation recently, and just because we wanted to, because we love him, really. He's actually one of the best teachers. I don't want to be all mushy, but really one of the best teachers I've ever learned from. Don't let it go to your head, Dominic. But so we asked him to come and talk about the work that he was doing on StackBlitz, and he just mentioned WebAssembly. Like he wasn't really going into it, but he gets excited when he's talking, and he mentioned WebAssembly, and a lot of people in the audience were like, "Oh, can you talk more about that?" Well, he can, but he kind of would scramble our brains, and so what I wanted was for Dominic to put together like just a little like demo, like a little like show us a little bit, right? And so the problem is he's busy with StackBlitz work, and he's doing really cool stuff with StackBlitz. And so it took a while, but we had to give him the time so that he could actually put something together and bring it back to show us. And today's the day, y'all. So I'm going to just shut up and introduce you to my friend, Dominic Elm, and he's just going to take it from here. And by the way, he's such a nice guy, and you absolutely should raise your hand if you want to ask questions or comment or anything, because this is really more fun if it's interactive. You know how we are. It's Angular Nation. You should talk. Dominic Elm,
thank you so much for the thank you so much for the introduction. That was very nice, and
so glad to have you.
So many kind words. I don't even know what to say. I'm really glad to be back on this show. And so, but something I want to mention is that I don't really have a slide deck, so this is going to be a bit of a freestyle, and we're just going to talk about like WebAssembly, what it is and why it's cool, and maybe the use cases. And what I would like this to be is maybe just us hanging out, talking about WebAssembly. And if you have any questions, like feel free, you can always interrupt me. I'm not just here to have like a monologue or something, so we can just have fun and talk about this awesome topic.
And Dominic Elm freestyling is the coolest thing ever. I'm just saying.
Yeah, it's just because I was so busy. Like I was working on a new feature actually. I know it's not related to WebAssembly here, but I was, because Bonnie mentioned that I work for StackBlitz, and I was working on a new feature, which is basically allowing ESM, so ECMAScript modules, to be used on StackBlitz. And that got me like pretty busy for a couple of weeks. And that's why I didn't really have a chance to prepare like a proper slide deck or anything. But I still think
you don't need a slide deck.
Yeah.
But you have a little code you can show us while you're talking through it? Because that's the only thing really that you didn't have last time, was like something that we could see.
Yeah.
Because we were getting so excited. We're like, we want to see it, Dominic. And you were like, I don't have time right now. So now you have something that you can show us, and we could. This is so exciting.
We're gonna live code something for sure. Yeah.
And we're gonna start at the beginning, because some of us
have never seen. We're gonna start all the way at the beginning. Yes, totally.
Go.
So what I thought for this is I'm gonna walk you, like, we talk about what WebAssembly is, the use cases, where it came from. I don't know who has already a little bit of experience with WebAssembly. I know, Taras, you said you mentioned WebAssembly.
No, I just saw some course that to use it, and it was like
we know how to spell
small intro, yeah.
Okay,
we know how to spell it. That's it.
Right. So maybe we can just like start at the beginning. Like if I had to explain WebAssembly to all of you, I would say, so I think it's important to understand where it came from. And I think in most cases, the reason for WebAssembly to exist in the first place is performance, I would say, in most cases, and like size of our applications. Like we all know that, the Angular team does a really good job trying to minimize the bundle that is generated. The React team does the same. So time to load and time to interactive is very important for like front-end applications, right? We want our applications to load instantly, and we want them to be fast. And JavaScript generally does a really good job. But the problem is that there is many other existing applications where JavaScript might not do the best job when it comes to performance. And so back then, there was something called ASMJS. I don't know if you've heard about it, but you can. So ASMJS is basically a compiler which compiles native code into JavaScript. And it did pretty fancy stuff, basically. So you could take a C application, so an application written in C and C++ or any other language, and compile it into JavaScript. That sounds crazy, but that was the back then. That was the idea, that already made so much possible. And we could run like games actually written in C or C++ and run them actually in a browser. Like that's pretty mind blowing to me. But the thing is that ASMJS compiled to JavaScript, and still we basically were left with, well, I don't want to say JavaScript is slow, but we can do better. And that's basically when we started to invent WebAssembly. So WebAssembly is the next generation of ASMJS. But the difference is, and sorry, normally I would have like slides and you could follow. I hope it makes sense what I'm saying here. So WebAssembly is a compile target. But so we basically take applications written in native languages, such as C, C++, or Rust, and compile it down to WebAssembly. And WebAssembly itself is a binary format. So we don't take those applications and it does in English is my second. Oh, am I too fast? Because I'm reading the chat, but okay. Anyways, sorry.
What are you saying, Rob? You want him to talk slower, or are you being silly? Rob's from Brooklyn, by the way. Yeah, okay, he's giving you a hard time, Dominic.
By the way, English is my second language, so I hope I'm struggling here.
No, you're great. You're great. We have people from literally from all over the world. So most of us do not speak English natively, so it's fine. I'm struggling with Dutch myself, so we're doing great. Your English is way better than my Dutch.
Okay, thank you. All right, so anyways, so ASMJS was meant to compile languages such as C or C++ to run on the web. But the goal was not to run those languages on the web. I mean, yeah, that's one thing, but we also wanted to run them efficiently. However, as I said, WebAssembly basically took this to the next level because it doesn't compile those languages such as C or C++ to JavaScript. It basically compiles it down to a binary format. And that's what WebAssembly is. It's almost like an assembly language. And it is extremely optimized. And that's basically what WebAssembly is in a nutshell. So all you need to know for now is you can write programs in other languages other than JavaScript and run them on the web using WebAssembly. Okay, that's basically the bottom line. I mean, that's it. I mean, there's more to it. But that's if I had to describe WebAssembly. Now, there is a whole bunch of like good examples for WebAssembly being used on the web already. Oh, also I want to mention that ASMJS is not a thing anymore. Like that was used back then, that's years ago, but essentially it was replaced by WebAssembly these days. And yes, okay, sorry if I stop for a second. I'm reading the chat and trying to answer questions. Yes, I mean, technically there is a limit, but that limit depends on whether those languages actually compile to WebAssembly. So technically any language could be compiled to WebAssembly if that language supported it, right? So right now, Python, for instance, that's a limitation. Python can currently not be compiled to WebAssembly. There is some effort done on that front so that, you know, at some point we might be able to run like whole Python programs and compile them to WebAssembly and run them on the web. But currently that's like not really a thing. So right now, the most popular languages for to compile to WebAssembly are C, C++, Rust, I think, is my favorite. And I've also used Rust actually for parts of like StackBlitz, like the web container. So I really, really like Rust. And then there's also Go. Like Go is also compiled to WebAssembly. So there's a handful. But you know that list actually gets bigger and bigger. So more languages can compile to WebAssembly. And Java cannot compile to WebAssembly currently. And so, are there any questions so far?
I have another question. So
hold on, wait. Nick, Demaya's had his hand up so patiently this whole time.
Hey,
and then Nick's next.
Can you hear me?
Yes.
Yes. Don't forget to put your hand down.
So
and anybody else that wants to ask a question, you can put your hands up too.
So I was wondering that I think there was a version of AutoCAD, if I remember correctly, which is now available on the web as WebAssembly. So I was wondering, so all these big softwares which are written in other languages, which were supposed to be run in a desktop environment, but is now available to the web, how would you although the performance would be great, but how would you load it, that huge application in a browser? Like, it would take a huge amount of time to load. So how does that scenario work?
You mean if you have really, really big native applications such as AutoCAD?
Yeah, is there a feature like lazy loading, or somehow you can adjust that?
Yeah, so if you compile really, by the way, I want to share a link with everyone, which is an awesome list of like languages actually that support, like there's a whole bunch. Like I only mentioned a couple. Sorry, I'm going to come back to your question. But if you actually click on that link, you can see a list of like, languages that do compile to WebAssembly. There's a bunch. You can also actually see that there's Java in it. So actually, it seems that there is some compilers which compile Java to WebAssembly. I'm not using that, but yeah, it seems there's also a lot of work. You know, this is changing like very frequently, and like things are added and removed and whatnot. So yeah, it's a very very vital ecosystem. To come back to your question, if you have very large applications, you compile them to WebAssembly, which basically you end up with a binary file. Then you can instantiate that binary file by streaming it. So it's not that you would block or something. You could either load it in the background. Technically, you could also, and that's the great thing about WebAssembly, is that because the way that WebAssembly binary or the format is structured allows you to stream it, but then technically you could already start executing parts of it. And that's the beauty of it, because, you know, as you go, you would stream in the whole binary, and then you could already do stuff.
All right, thanks.
And yeah, so AutoCAD is actually a really good example of this, because it's a super old program by Autodesk, and I think they started developing it for like 30 years ago or something, and it's huge, right? It has lots and lots of features, and it requires really a decent amount of like performance. And they actually compiled that to WebAssembly now, and it runs on the web. And then some other use cases, like for us as front-end developers, I think WebAssembly, you might not use WebAssembly on a daily basis. Like that's not something you would use like I would say for most regular like front-end applications, I would say. In my opinion, it really shines if you have something that is performance critical. Like for instance, Dropbox, compression and disk space is very important for them, right? Because they have to pay for all that storage. And so for Dropbox, it is super important to compress those files. And you could also upload something from a mobile device. And what they've done is they've done a lot of research and came up with a new compression algorithm, which can actually be like it can be implemented in a native language such as C, and it can be compiled to WebAssembly, which basically allows you to have a very optimized and efficient compression algorithm right on your mobile device. Where normally compression happens maybe on the server side, you would upload an image, then you compress it, then it's persisted in a database. But now with WebAssembly and something that would actually require a lot of performance, such as compression, you can do that on the mobile device. And the great thing about that is that you also save bandwidth, right? Like if you compress it on the mobile device or even on the client side, like on my computer here already and not on the server side, I don't use that bandwidth. I don't have to send like, let's say a 5 megabyte file to a server, compress it there, and then put it in a database. I could already compress it down on the client side to, let's say, 1 megabyte, and then I only have to upload 1 megabyte, which is going to be much faster than uploading 5 megabytes, right? If that makes sense. So there's a couple of really nice use cases. And another one, I actually don't want to talk, I actually want to show this demo, but maybe one more example.
I was going to stop you from, yeah, because we have a couple more questions too.
Oh yeah, sorry. Yes, Figma also uses WebAssembly actually. Like that design tool used on the web. There, I think Canvas or something. I think it is the Canvas, like the whole stuff, you can do and design stuff. They use WebAssembly because that whole thing is written in C++. That's also a really good use case. Yeah, so I guess, there's a couple, but I would say it makes sense to use WebAssembly when size really matters and if performance really matters.
Okay, let's, and you have some, because I don't want to run out of time before you share your screen. Yes. But we have a couple more. We have, Nick has a question and Terrace also has a question. Okay, let's maybe get to those questions.
Yeah, so my question was about, because in JavaScript you have like these execution engines, for example, like V8 and that kind of stuff. And I think there's probably multiple execution engines. Does WebAssembly work in a similar way that has like these engines? And then also follow-up question, like which browsers currently support this?
So WebAssembly is standardized by ECMAScript, right? By the ECMAScript specification. So essentially, it's something that normally every browser should understand if those browser vendors really implement a WebAssembly engine. So it really matters. Like what's important is that WebAssembly runs on a host, right? It's a binary file that runs on a host, and you would always compile a certain language, given a certain, like compile your program for a particular host. So right now it's very difficult to have one WebAssembly compiled for different hosts. For instance, you could also run it on a Raspberry Pi and some other like platforms, but the host might be different, right? Mm-hmm. And so in a browser, the host would actually be, well, in Chrome, it's actually V8, which would execute your WASM, right? And so your program is specifically compiled to a specific host, because that host gives you certain functionality. And also something I want to mention actually is that WebAssembly is somewhat limited. You can call functions from WebAssembly. You can call JavaScript functions from WebAssembly, and you can also call WebAssembly functions in JavaScript. So it's basically in both directions. You can call functions and pass values. But something to understand is that there's only numeric types in WebAssembly. So essentially everything is represented as numbers, right? So there's no notion of strings, which we have in JavaScript, right? So it's a UTF 16-ish type strings, and JavaScript understands that, but WebAssembly doesn't. So every string you would pass to a WebAssembly has to be encoded into numbers. And so, that's currently one of the things that these browser vendors try to optimize for. Like it's the whole encoding. If you pass like these values, which WebAssembly normally does not understand, trying to optimize that, because it has to copy the whole string and then copy the memory over and like all of that stuff. Those two they don't really share anything. And also from the WebAssembly, it's also a limitation that you cannot access the DOM, for instance. So you could not have a WebAssembly running somewhere and then manipulating the DOM. That is a hard limitation currently. For instance, if you have
also one of my questions, if you could manipulate the DOM.
Yeah, no, they're trying to work on it, and this is where essentially it's called WebAssembly interface types come in, more or less. So they have like a lower and upper, APIs to basically convert a type into something that WebAssembly understands. But yeah, you cannot really talk to the DOM, manipulate it. The host has to provide functions it can call. And so you would essentially, if you want to do anything on the DOM, you would have to serialize those objects and, then provide them as imports to the WebAssembly module. And then from within that module, you can call those functions. So, that's basically how it would work.
You're saying that the host provides functions. Is it
correct?
Is it like a WebAssembly then like an interpretive language, and the host is like an interpreter of the WebAssembly?
I mean, so it's binary, and it does get compiled into machine code by V8. But you can it's just the way how that memory is structured. So I can show you in a second, but essentially there's different sections in that WebAssembly module, what we call it, and you can pass in imports and exports, and that the structure is very important and fixed. And that's how you pass in functions. And then, it's basically just pointers. And then while executing the WebAssembly code on the machine, then it's just like, the pointer and then calling those functions, more or less.
I want to see it. Wait, we have one more question. Do we have time for Terrace's question? And then we can, because I really want you to share your screen. I'm getting really excited.
Yes.
It's really small.
He answered your question, Nick? Yeah. Okay, go ahead, Terrace. Don't
Dominic,
forget about you sharing your screen, Dominic. I'm really excited.
Yes.
I'd like to ask a question about performance. You said that JavaScript frameworks are doing a great job optimizing the bundle, but WebAssembly will do it better. In all cases, or just some specific areas? And it depends on.
You mean why? So are you asking why WebAssembly is faster than JavaScript?
No, I mean WebAssembly is faster in all cases, or just some specific?
No, I mean, I think you can generally say that WebAssembly will always outperform JavaScript. I think WebAssembly will outperform JavaScript, especially in those cases that require a lot of compute. Like in very simple. So in my demo, I actually have a calculator. So we built a super simple calculator, which everyone understands. But in this case, the calculator is something that I guess it would actually add overhead to it, because you would, even though the communication between JavaScript and WebAssembly is very optimized, and like all of those browser vendors, they do a lot to optimize this, but still, I think you wouldn't see a lot of gain by using your calculator and compiling it to WebAssembly, rather than just having your calculator written in, let's say, JavaScript. So if it requires a lot of compute, there's some like nice blog posts about performance and comparing it to JavaScript, and it's really like Fibonacci, for instance. If you would calculate the Fibonacci number, like a very large one, then WebAssembly would perform better.
I understood. Thank you.
Okay, cool. So should we just take a look at the demo and live code something?
Yes.
Okay.
Set up a table of money.
Okay, I'm just gonna. Oh, whoops! Turn off my video.
What happened, Dominic?
Let's see. All right.
Yes, Federico. This is the moment we've been waiting for. We want to see
this.
Yes, we can see it. We're very excited.
All right. So what we're gonna do is, so the easiest way, by the way, to get started with WebAssembly is to to start with assemblyscript. Oops, it's another word. Yeah, it's another thing. So I actually, well, I think I lied a little bit when I said you would compile native languages to WebAssembly. That is true, but there's also something called AssemblyScript, and that, in my opinion, is a very low barrier of entry if you want to start with WebAssembly. And I think it's a really good first step into like of dipping your toes into the water. And it's here, AssemblyScript. I can share this in the link in the chat here. So this is AssemblyScript, and what's great about AssemblyScript is it basically has a very familiar syntax to TypeScript, right? And we all probably use TypeScript on a daily basis, so we're very familiar with it. And AssemblyScript looks very much like TypeScript. So you have these types, but the nice thing is that AssemblyScript takes this TypeScript-ish language and compiles it to WebAssembly. So we don't have to learn Rust, for instance, in this case. If we just want to play around, we don't have to learn C, C++. We can just use this and use a very familiar syntax, which is TypeScript-like, and compile that to WebAssembly. And this is what we're going to do. So we're not going to look at Rust because I think that's just going to confuse.
Can you make it bigger, Dominic?
Yes, I will.
Thank you.
So, and yeah, so it's super easy to get started with this. And so I thought we're gonna do this, and we're gonna create a new Angular application. So I hope that my machine does what I want it to do, because I noticed lately that if I'm sharing my screen, that my machine gets super slow. So, oops, I think I need to make this bigger as well, right? Is this good?
It's a little small.
Oh, still. Whoa.
There you
go. What about this?
That's beautiful. Yes.
Okay.
Yeah, beautiful.
Oops. Okay, so we're going to create a new Angular application. But everyone's familiar with Angular here, right?
Yes.
Okay.
This is Angular Nation, man.
Yeah, I know.
Well, we at least know a little bit. Yeah.
Sorry. Yeah. Okay. npx Angular CLI. So we use the CLI to create a new, and we call it ng. Let's call it ngwasm here. Oh, hopefully it's not too slow here. Let's see. How much time? Okay, we have enough time.
Don't worry.
Yeah, okay. And in the meantime, you can always feel free to ask questions if you have any.
What are you listening to on Spotify these days, Dominic?
Oh, I listen to a variety of different genres. Actually, right now I listen to a lot of, would you like Angular routing? No, I don't want that. CSS, just house music and stuff like that, electronic music, I like that. And country music. I still have Sam's playlist, which I really listen to a lot.
We do too. Since we left Texas, we get homesick sometimes, and we play our country music.
All right. So, and then I do have my documentation here, and see there's also something like a quick start, and it tells us we have to install these dependencies. So there's a loader, so we can actually load the WebAssembly, and then there's the actual compiler, which would walk over the AST, the abstract syntax tree of our TypeScript file, and compile it into a WebAssembly, a WASM. Okay, so this is installing. I knew it was going to slow.
That's okay.
Yeah, so I highly recommend to just play around with AssemblyScript a little bit and write like simple programs. I could like go on and on and on. I actually thought that I could, because I do have a few slides actually, because I was preparing a talk. And so I thought I could actually also like talk about like how V8 works and why JavaScript and why WebAssembly is faster than JavaScript, but I guess I don't really have the time for that, unfortunately. There's a hand.
I have one short question. Are there any new security concerns that we should worry about with WebAssembly?
No, I mean, so these days, of course, there's always like bugs in the engine, and you might run into buffer overflows, and like these things, but actually you don't, because most of the bugs have been, I would almost say, ironed out, and the bugs you would encounter or security vulnerabilities, I would say are very, very rare. Like WebAssembly is pretty secure, especially in a browser, because the browser is so secure and it has this super secure sandbox, right? There's another question. Okay, so we're gonna cd into ng-wasm. We're gonna npm install our assembly script loader and assembly script, and we're gonna save these as def dependencies. There's a question.
Tom Eustace has a question. We like Tom Eustace. He has good questions.
Hey. No pressure. Hey, Dominic.
Hi.
So I heard the term WASI a while ago, the about interacting with the kernel, or I was just wondering, could you explain a bit about that and what it brings to the table?
Yes. So with actually, yeah, that's a good point. So with WASI means WebAssembly System Interface, and it means that we would give our WebAssembly module actually access to kernel level functionality. For instance, that could actually be something like with WebAssembly interface types and WebAssembly system interface, like WASI and the interface types, that would more or less allow us even to communicate with the DOM potentially, right? So it's not only like kernel level functionality, but it could be also host dependent functionality, for instance. And it could be that, because Chrome has the Chrome FS API, that with WASI, you would actually have access to a very, not the full-fledged file system, but you would have access to some sort of like file system, for instance. But WASI is still like being worked on, so it's you can still build something. Actually, there's a nice repository that I'm going to share later, which demonstrates WebAssembly and WASI with the Chrome FS API, and it's very, very powerful. Does that maybe answer your question a bit?
Yeah, you're very, very powerful, great. Dominic Elm.
Okay, I'm going to make this bigger. So let's not make this too complicated. So I have my Angular application here. And what I'm going to do is we will build a very simple calculator here. And so, I have my app, and I'm going to create a new folder and call it calculator. And then inside calculator, we have a calculator dot. And here's the thing, TypeScript. So it's very familiar.
Dominic,
yes.
I know that you start talking faster as you run out of time, and I just want you to know we don't care if you go over the hour. Like, we're recording this, so I know you have work to do. I'm just saying it's okay. Don't worry. So
I actually have another meeting.
You have other work to do besides hanging out with us?
Yes.
Rude.
I'm sorry. No, okay. I'm gonna slow down if I'm too fast. So
no, I just wanted you to know that it's okay with us. But,
okay. Mm-hmm. Yeah. Thanks. And so what I just did is I created a TypeScript file, and that's the beauty of AssemblyScript. So you can just take any, well, you can't really take any TypeScript file and compile it to WebAssembly, because AssemblyScript requires you to adhere to certain rules, like, because WebAssembly only supports numeric types, you can't, for instance, do something like some map and assign it an object. Like this doesn't work, because AssemblyScript has no idea what the type is. And that's essentially, like, for WebAssembly to work properly, it needs those type informations, right? And this is just an object, and it doesn't really know what this is. So if you wanted to have maps, that's totally fine. And WebAssembly and AssemblyScript does support that. But you'd have to use the ES6 map type, because with this map type, we can actually give it proper types, right? So this would work perfectly fine with AssemblyScript, and you can just compile it, but not just the object literal. That doesn't work. And then, okay, so we want to build a simple calculator, and let's just say we have some function which adds two numbers. And so I can just simply write, I can export a function. And when I'm using this export keyword here, you're going to see if I show you the WebAssembly text format, which is basically a text format that represents the binary, the WASM itself, you're going to see that that function gets exported. And that's also when I show you like the different sections. Okay, so if you want to export a function, you would do that in the same way as you would export a function in just, you know, a TypeScript file. So we have an add function here, which then important, it has to return a number, and it actually takes a number. Oh, I want to give this A and another number B, and then this simply returns A plus B. Okay. So here's our simple function. Now this looks pretty much like TypeScript, doesn't it? But now what I can do is I will open up my terminal here. Okay, wow, it takes forever. And then I'm gonna use the assemblyscript compiler. Okay, and I will point it to source app calculator, and then my calculator TS, and I can specify the output file. And the extension of this output file basically controls what file it's gonna produce. And so I'm gonna compile this calculator TS into our asset folder. So I have to go to up, then, oh, isn't there, where am I? Oops. Huh? Oh, I'm actually inside, oh, never mind. I was not inside the calculator. So I have source assets calculator.wasm, okay? And now if I hit enter, and we take a look at, yes? Sorry?
You probably have to save the calculator.ts file.
Didn't I save that? Oops. Okay, let's do it again. But we already have a WASM file here. See? So this is the assembly script compiler. So we have to run it through the compiler because, you know, this is like assembly script here, which looks like TypeScript, but it has to be compiled into WebAssembly. And so WebAssembly, if I click on it, it says, well, it's a binary file. And that's what it is. WebAssembly is a compile target, and it's binary. So if I were to text dump, look at the source assets and then the calculator WASM, you would see a whole bunch of like hex values which represent binary, right? So it doesn't tell us that much, and we don't really know what's inside unless you understand hex. But there's another way, and this is a nice extension for VS Code, which is called WebAssembly, I think. Yes, it's just called WebAssembly. And I would highly recommend to install this WebAssembly extension. It's from the WebAssembly Foundation, and it allows you to right-click on this WASM file and then click on Show WebAssembly. And voila, it shows us what the WebAssembly really looks like. So this is what we call the WebAssembly text format, the WAT, W-A-T. Okay, so it's a text format, human readable text format of that WebAssembly module. And you can see that it has a whole bunch of like sections in it, right? We don't have to understand all of this. You know, it's not super important unless you really want to go into this and optimize and do crazy stuff with it. But it's not important to understand this. It's just essentially what it looks like. It might be important to understand that there's different sections, and you can see here, for instance, I'm going to make this slightly, oh, I actually can't change it. That's unfortunate, but I can take this and put it into another file so I can change it. As you can see here, see, this is WebAssembly. This is our function. It's an add function which has two parameters, returns a number, And WebAssembly is a stack language assembly, right? So it's basically operating on a stack. And that's why you can see it grabs this, first parameter, it grabs this another parameter. So it's basically from top to bottom. So it's essentially a stack, okay? And then it adds those two numbers. And so this is our function. We export this function so that, when we instantiate this WebAssembly module, that we can call these exports from the JavaScript world. And technically, we could also import functions. So we could have a section in here which says imports, and that's all the functions we could call from within this WebAssembly module, which are essentially just, references to JavaScript functions, which is pretty amazing. Okay, so this is the our WebAssembly file now. And in order to get this wired up, I'm just gonna quickly remove everything we have in here in our app component HTML. And okay, just remove this. And oh man, my machine is slow. Okay, so what we're gonna do is now we have to load that WebAssembly, right, in order to call it. Like, what does that look like? How can we actually use this? And this is where the assembly script loader comes in. So we have to fetch our WebAssembly. There's different ways we can fetch them. We can either just fetch it and then instantiate the module, or we could also like instantiate it and like stream it and instantiate it like step by step. What we're gonna do is we're just gonna simply instantiate this. So this is assembly script loader, which exports a function called there's instantiate streaming. So here it says it would asynchronously instantiate an assembly script module from a response. It's just streaming it byte by byte. This instantiate would take a response and instantiate it like as a whole. And we're just going to use this instantiate function. And then we're just going to create an ng on init function here. This is really, you would probably put this in a service. You wouldn't do this in a component, but it's just, for this demo, we're going to look at how we can use this WebAssembly module now. So inside our ng on init, we can then call instantiate. And if we look at the signature, it tells us that it can either take in a WebAssembly module, a buffer source, response, or something, which is a promise of these. And so in order to get this WebAssembly file, and if we remember, we actually compiled it into our asset folder, we can just simply fetch it over the network, get that as a response, as a byte array, and that byte array then represents the WebAssembly module, which then gets instantiated under the hood. So the browser does support, like the browser has this primitive called WebAssembly.instantiate. This is basically what it calls under the hood. This is what the host, this is how we tell the host, here's our binary, it's our WebAssembly module, which is just a whole bunch of numbers. And then we call instantiate, like WebAssembly instantiate, on that host. And that's going to kick off, in Chrome, for instance, V8, to compile it into machine code, to optimize it, and to execute it. Okay, this is just a convenient API, like a nice wrapper around basically what the host does, or what the host gives us. And so in this case, we can call fetch, and we're going to fetch it from our assets, and we called it calculator.wasm. And this, so the thing is, Webpack, at least if you use Webpack 5, it does support inlining WebAssemblies, which then means it would basically inline the whole, like the array buffer into your bundle, which means that instantiation would be synchronous. However, in this case, instantiation is actually asynchronous. Like in most cases, it is actually synchronous. Okay, sorry, asynchronous. Because, well, it's asynchronous because we have to fetch it, we have to wait for it. All of those APIs are asynchronous. And so what I will do is I will essentially convert this into an observable by using from args. Wow, these imports are really bad. Okay. Oh, it was correct. Okay, so we're going to turn this into an observable here. We will add a property called ready, which is an observable of Boolean. And let's just, give this an initial value because we're in strict mode. So initially it's not ready, and we're going to use this inside our UI so that we can maybe show something, show a loading indicator until this WebAssembly module has been loaded and instantiated. And then we can assign this to ready. Currently, this is not a Boolean, so we're gonna pipe this and add a map operator. And I don't know why my imports don't work. Operators. So we're gonna import the map operator. And so what this will give us is basically the module, the instantiated module, which then has imports. Well, it would have imports if it had some. It also has exports, and we're going to inspect this just so that we get an idea of what this is. And here we just say, okay, if the map gets called, we just return true. So we map this whole thing to true, and this is when we know it's ready. So I'm going to leave the debugger here, and in our component, I will just add a diff real quick with an ngIf, and ready $async. So we use the async pipe here, and maybe as a text we can just simply say ready. Okay, then we're going to serve this application. Oh, I'm so confused with all the start script. Sometimes it serves, sometimes start, sometimes this. Okay, so here we go. Hopefully it doesn't take too long here. Well, in the meantime, we're already going to implement a function here which says add. It takes an A string, B string. I know these are strings, and our WebAssembly module expects numbers, so we have to convert them into numbers then. We also have to track and put our module actually into a property, and we can just call this module maybe. This hashtag here in front is actually like ECMAScript private fields. This is an actual private field, so it's not just like TypeScript syntactic sugar and making it private. Like the hash symbol is actually private, so it cannot be accessed, which is really great. So if you compile your application, your front end to a modern platform which does implement these private fields, it would actually be natively private. Like there's no way you can access this, which is really great. So I really try to use these instead of private if I can. And then, well, let's just, for now, let's type it as any, because I don't want to waste time now with typing this. And so I will leave my debugger here. I will say this dot module is equal to my module. Okay, we put this here. It's compiled. We can go into our browser, localhost 4200, and see it already says it's ready. I'm gonna open my DevTools here, and we should stop at the debugger point. Okay, perfect. And now if we actually look at, see, like TypeScript now, because we haven't configured it, TypeScript actually converts those private fields into something that is polyfilled, because we didn't tell it that we actually run on a platform which natively supports these private fields. This is something you can configure though. And if we take a look at the module, I don't know if you can see this. I'm trying to make this bigger as well. Is this big enough? Oops. This was too big.
Dom, make it bigger.
Ah. Okay, so yeah. Okay, I'm trying to navigate. Okay, see, here's our module. And if we take a look at the module, okay, I'm just going to print it here. Whoops,
by the way,
easier.
I don't ever want you to leave, but I just want to remind you that we're almost at the top of the hour.
I know. So
but I don't want to tell you that because I don't want you to leave.
No, it's fine.
It's so
I can go 5 minutes over. So we have the module. You can see it has an instance, which is actually the WebAssembly instance. So it's an instance of this WebAssembly module created by the host. We don't really have to look at this. It has the module, which is also the native module. And it also has exports, as you can see. And see, it does a whole bunch of it has some helper functions in order to communicate properly with the host. And that's what I mean. It has to be compiled to a particular host, because if you would pass in a string to this WebAssembly module, there has to be some glue code in between that translates a string into numbers. So it has to encode the string into something that the WebAssembly module understands. And that depends on the host, because for instance, the browser in V8 has UTF-16-ish strings. And so, it really depends on the host what that glue code does. But you can also see that, we don't have a table, we have some memory. So every WebAssembly module gets memory allocated to store variables, local variables and whatnot, and have some global static values. And we can also see that we actually have a function. See, so the host has compiled this function into something that we can actually execute, right? So if I would, well, it's the location. If I would click on it, it actually tells us, oh yeah, well, it doesn't really, debugging WebAssembly is currently not so nice, but they're trying to improve this experience. But what's important is that there's exports, and we have one exported function, which is something that we have implemented. So in our add function, we can then take advantage of this information and say, okay, cool. On our module, there is exports and there's an add function. And then we just simply pass that string into the add function, and this plus sign actually converts it into a number, okay? And then we do the same for B. And let's just console alert. No, actually it's alert, just alert. And we're gonna alert this. And from our component, we quickly add a form, just so we can do something in our UI. Okay, so we add an input field here, which has a name of a ng model. We add another one and give it B. Then we have a button which says add. And then we have to get our ng form instance and call ng submit and pass in our form. Maybe I just call add and then form.value.a and form.value.b. Okay, so we just simply get our values from our form here and pass them into our add function, which we've just implemented here. And then it's going to alert the result. For this to work, we have to add in our application module here the forms module. Forms module. I'm going to format this. And I think it should be happy if I didn't make a mistake here, which I normally do. Yes, it is compiled. Ta-da! Do we still have the debugger here? Huh? Yes. Oh, beautiful. This is a nice UI. Yes. Okay, so now we can say, okay, 100 plus 10. Who knows the answer? Hopefully it's 110. Let's see. And it's 110. I don't know if you can see this, but I I think I can't make this bigger. It's the alert.
That's okay.
But trust me, it says 110 here. So yeah, this is basically my super minimalistic introduction to WebAssembly and showing you how you can like get started with it in an Angular application. I hope it was useful and helpful and interesting.
That was amazing. I think that was really cool, and it's because it's not exactly Angular, but it's really relevant to Angular. And I think that even if you're not actually using this, I just love the opportunity to keep up with like all the new things and the ecosystem and what's going on. So this was very cool. So I know you have to. I have another meeting too. We probably all have other meetings we need to go to, but I just want to say real quick. Does anybody have any quick questions for Dom? Okay, Demalia, go ahead.
Since you're working with WebAssembly for some time, what are the situations where you feel like this is where I would need WebAssembly? Like practical ones, which you have.
Yeah, as I said, it really depends on the application. So for instance, I can give you an example for a web container, which is stack bits. So what I've done is I've implemented a file system, like a Unix file system, in Rust and compiled that to WebAssembly because, well, you need a file system, right, for Node programs to run properly. And that is one of the most important parts when it comes to like running Node. Obviously, there's way more, but a file system is something, and it has to be really fast. And so that's where I'm using WebAssembly. Another part where we're using WebAssembly is for the crypto APIs, which have to be quite, efficient. Like if you, compute some hashes and whatnot, that has to be really efficient as well. I mean, for a lot of like, just as I said, for most, let's say, ordinary front-end applications, I think there's not that many probably applications to WebAssembly. It's more like for these, like the containers we build, or if you have to do some heavy compute on the client side, or applications like Figma or Autodesk. If you build, these applications, WebAssembly makes a lot of sense. But like if you just build, let's say, a dashboard or something, I think there's not that many use cases probably, unless you want to optimize images, you want to crop them, you have a widget where users can like do things with that image, apply filters and whatnot. That's also something I would probably use WebAssembly for.
All right, that was awesome. I'm so sad that we ran out of time because I don't get to see Dominic Elm very often. But as always, Dominic, it's so cool to see you, and I know you're busy because you're amazing, and I really appreciate you taking the time out of your schedule to not only come and hang out with us, but also to teach us cool stuff. Thank you very much. Okay, so we're out of time. And this is the time, this is kind of a thing, I think, at the end of the call. This is the time for everybody to come off mute and say thank you to Dominic.
Thank you very much, Dominic. That's very interesting.
Thanks, Dominic.
Thank you,
Dominic.
Thank you.
That's very nice. I want to thank all of you for listening to me and like for having me on the show. Thanks.
It's absolutely our pleasure. All right, that's it for now. Dom, please come back and see us again soon and often. And we'll see y'all soon.
Yeah, see you, Dom.
If anyone has any questions, you feel free to, contact me.
Thanks.
Okay.
Thanks,
Absolutely.
Bye.
All right. Bye, everybody.
Bye-bye.
Bye.